Okay, so we have a character and we are moving. The only problem is we're stuck in this idle pose. And it'd be really nice if we could run around and jump and do all sorts of things. So for that, we need an animation blueprint. Now recall, if we go back into BP/character, our skeletal mesh component has the ability to use an animation asset or use an animation blueprint, as the animation mode here has a drop-down. And we can choose use animation blueprint, but we need an animation blueprint first before we do that. So what we're going to do is make an animation blueprint. And we're going to stick this animation blueprint right here next to BP/character. So to create an animation blueprint, we are going to right-click and go to Animation and select Animation Blueprint. Now, when we do this, we're prompted to select a skeleton, as an animation blueprint will be tailored for the specific skeleton we're using. We're going to choose Echo Skeleton and click Create. And we can rename this, and I'm going to name it ABP for Animation Blueprint _ Echo. So we have an animation blueprint. And if we double click this and open it up, here is the Animation Blueprint Editor. And the Animation Blueprint Editor has its own viewport, so we can kind of see the pose that our character has. And we also have an anim graph, this is new, as well as an event graph. And the event graph is just like the event graphs in our other blueprints. We can perform logic here, do calculations, whatever we want. Now, anim graph is different. The anim graph deals with poses, where the event graph deals with the flow of execution of logic. We're doing one thing, then another, whereas the anim graph has execution wires, but these execution wires represent pose information. They represent all of the different transforms of the bones that make up the current pose of our character. So this output pose here has an input execution pin. If we hover over it, it says animation pose, and that's why its icon is shaped like a little person. So we can plug in an animation pose here, and that's going to drive our character's pose. And if our character is using this animation blueprint on its skeletal mesh, then we'll see that in the game. For example, we can plug in an animation directly into this. And to the bottom right, we have an asset browser. Now you should have this open by default, but if it's not open, go to Window and make sure Asset Browser is checked, and you'll have this asset browser. And it shows you any assets that we can possibly use here in our ABP Echo anim graph. So these are all animations that are rigged to the skeleton we chose for this animation blueprint. And we can drag them in. For example, we have jog forward. If we drag this right in, then we have a node, and it's called a sequence player node. And remember, these are animation sequence assets, right? So when we have a sequence player node, if we plug that into the output pose and compile, now we see in the viewport the pose is changing, and it's changing very rapidly. It's in fact playing this animation. And because this animation is set to loop, we're seeing that animation looping. Now it's set to loop by default, and if we take our details panel and scroll down a bit, we'll see that our sequence player has a loop animation variable. And if we uncheck that, well, then we'll no longer be looping. And if we compile, we'll see that the animation stops after playing the animation a single time. And if we check it again, it'll just keep looping. So this is a way to drive our animations for the character. So I'm going to click and dock this tab up at the top so I can go into /character. And I'm going to click the viewport so I can see. Now she's gone back to her default A pose because we're no longer using the animation asset. I changed this to use animation blueprint. And the anim class allows us to select an animation blueprint. So I can search here for ABP Echo and choose that. And now we see that Echo is using our animation blueprint. And the animation blueprint says, use this for the output pose, this jog forward sequence player. So this is how we drive the pose for our character. And if we press play, we'll see that we're stuck in this running animation. Now, it doesn't look too bad if we're moving. So I can perhaps take this ground and scale it up in the X and Y. Remember, we can select two axes at the same time and scale them up like that. And if I press play and start running around, well, this looks great. We're running, and that solves the problem of sliding around that we had. But now there's a new problem. If I stop running, well, Echo continues the running animation, and that's not exactly what we want, right? And that's where the beauty of animation blueprints come in. We can choose to play different animations with different sequence nodes depending on data that we get from our character. That's why we have an event graph, so we can get data here from the character, and then we can harness that data and drive which animation should be playing based on logic. So in this lecture, we're going to set up some basic locomotion, and to have locomotion where we can change poses based on data, well, we first need some data. So in the event graph, we need to set up some variables that we can use in the anim graph. So here in the event graph, we have a My Blueprint panel, and there's a plus add button. And if we click that, we can add variables, we can add functions, we can even override some functions that have been exposed to blueprints. But what we want right now is a variable, and I want a variable for our character. So I'm going to call this simply character, and it's a Boolean by default, but we don't want a Boolean. I would like a variable of BP/character type, basically the type of my character blueprint. And we can change the type to that. We can search for BP_/character, and there's the option to choose that as a type for the variable. Now, there are 4 different types of BP/character blueprint variables. There's object reference, class reference, soft object reference, and soft class reference. The soft versions are what we call lazily loaded. They don't actually have any value until those objects are needed, and then they're loaded. So these are more or less file paths that point to where this particular asset would be in our project. Now, object and class references, these are regular variables. An object reference is essentially like a C++ reference to an object, whereas class reference is like a variable that holds a type. So out of all 4 of these, the most similar to a C++ variable that you'd be used to would be the object reference. If we select that, we now have a variable here in Blueprints called character, and its type is BP/character. Now, this is sort of like a null pointer when we create a pointer variable in C++. It's empty, it's uninitialized, it holds an address, but until we initialize it, that address is meaningless. Same thing goes for blueprint variables as well. So if we click and drag into the event graph and click on Get Character, well, we do have a character node, but it's not necessarily a valid variable. It doesn't necessarily have any meaningful information in it. And in fact, we know that it doesn't, because we just created it. We never initialized it. So we can initialize it, and to initialize it, we need to get our character. Now, this animation blueprint has the ability to get the owning pawn. Any pawn that has a skeletal mesh component that's using this particular animation blueprint is considered to be owning it. And as soon as we set our mesh to use this ABP Echo animation blueprint, BP/character became the owner. So if there exists an actual object in the game at runtime using this animation blueprint, the pawn that owns that skeletal mesh component is the owner. So we can get the owner with a node called try_get_pawn_owner. Try_get_pawn_owner is so common that you see that there's already one here for us. It's grayed out because we haven't started using it, but it's here. It's ready for us to use. Now, this other node that's also grayed out is called Event Blueprint Update Animation. And look, it has delta time X. Now this is just like the tick function in that it's called every frame. Every single time our animation is updated, this gets called, right? And there's also a similar node to begin play. And we can get one of those by right-clicking and searching for it. And it's called Event Blueprint Initialize Animation. This is just like begin play. It's called once at the beginning of the game or when the owning pawn is spawned, and we can use this to initialize things early on, such as setting the value for our character node. So here's what we're going to do. We're going to use try get pawn owner. But try get pawn owner returns a pawn object reference. Remember, character is a character object reference. So we can't just take character and drag it in, get a setter, and connect these nodes. You'll see that we have a message that won't let us connect these nodes. It says pawn object reference is not compatible with BP/character object reference. So we cannot take a value of the parent type because pawn is the parent to our character variables type. We can't just take a parent type and stick it into a child. We know that we can take a child object and point to it with a parent pointer variable, but we can't go the other way around. So we have to cast. So that's what we're going to do. We're going to drag off of try get pawn owner and cast, and we're going to cast to BP/character. And once we've done that, the cast node will return a BP/character value, and we can use that to initialize our character variable. Now we do need our nodes all connected so that all of this is reached by the flow of execution. Now this is great that we have a variable on our animation blueprint now that actually stores the value of the owning pawn cast to a BP/character, because now we can access any variables on BP/character. Now as the character, we also want that movement component. Remember, characters have the character movement component. And the character movement component is where all of the data pertaining to movement resides, at least most of it. We have the ability to know if we're in the air, if we're falling. We have the ability to get our character's velocity and know how fast they're moving. So for that reason, we would like the character movement component as a variable here in the animation blueprint as well. So we can drag off of our setter for character and type get character movement. And all the way down at the bottom, if we scroll down, we have get character movement. If we click that, we get the character movement component. And we can store this in a variable as well. Now, to create our character variable, we've clicked plus, add, and chose variable. Another way to do that is to click the plus icon down here in the variables section. And yet another way to create a variable is to take a value returned from some node in Blueprints and promote it to a variable. This is sort of a shortcut to creating variables and setting their values. So if I drag off of character movement and release, I have the option to promote this value to a variable, and we automatically get a new setter node for this new variable. And by default, it's given a name. It's called character movement. And we can rename it if we want to. I can click down here in the My Blueprint panel and call this movement component. And now it's renamed. And we do have to connect these nodes in order for this setter node to be reached. And now at the beginning of the game, we're taking our pawn owner, casting it to a character and storing that, and then getting the character movement component and storing that in a variable. And now we can access these values. So I'd like to access them, and I'd like to access them every single frame, because things like velocity or whether or not we're in the air, whether we're falling, those are things that can change from frame to frame. And if we're driving our animations based on that data, we need real-time updated values, right? So here's what we're going to do. We're going to take our event blueprint update animation, which is like the tick function. This is going to be called every frame, and we're going to update some variables. So first, I would like a speed variable, but More specifically, I would like ground speed, because if our character has a velocity, that is a vector that has a direction and a magnitude. That's what the velocity is. It's a vector. So if our vector is pointing upward, or at least has some z component to it, well, I'm not that concerned with the z component of my velocity. I want to know the xy components of my velocity. I want to know how fast we're traveling parallel to the ground, as that's really what should determine our running status and things like that. So what we're going to do is we're going to take our movement component, drag that out and get it, because the movement component has the ability to get velocity. So we're going to type get velocity and scroll down to the bottom, and here's a getter for the velocity, which is stored on our movement component. So this is the vector whose magnitude, whose length, is how fast we're going. That's how velocity vectors work. Now, we can always get the magnitude of a vector here in Blueprints by dragging off of it and typing vector length. So vector length will calculate the magnitude. We've seen how to do this on the whiteboard. This Blueprint function does the math for us. Now, I know we're doing a lot of things in Blueprints, and you're probably wanting to know if we can do this in C++. And yes, we can. There's really no reason to do it in C++ versus Blueprints. It's kind of a preference thing, but don't worry, we'll learn how to do this in C++. We're just kind of getting our feet wet introducing the animation blueprint at this point. Now we can get the vector length. We can also get the vector length xy. This is basically the vector length without the z component, which is really what I'm interested in, right? I don't care about the vector's z component. I just want the xy components of my vector. So that's what vector length xy is going to give me. So this gives me the length of the vector with the z component zeroed out, right? And this is what I'd like to promote to a variable. So I'm going to drag off and promote this to a variable, and I'm going to call this ground speed. So we now have a float value ground speed. And since it's connected here to event blueprint update animation, this is updated every single frame. So as our velocity vector changes, our ground speed will change as well. Basically, if we're standing still, this is going to be 0. And if we're moving, it's going to increase and get larger. So we can use this ground speed to drive our animation poses. And we do that in the anim graph. So we have jog forward, but we'd like to be playing the idle animation if we're not running, and the jog animation if we are running. So how do we do that? Well, we do that by creating different states that we can transition back and forth to and from. And to transition between different animation states, we have to create something called a state machine. So here's how we do it. I'm going to go ahead and delete that jog forward animation and make a state machine. So we can right click and type state machine. And here's the option to add a new state machine. So click add new state machine, and we now have a state machine, and it just looks like a black node. And we can click on the name to rename this. I'm going to call this ground locomotion. It can have spaces in the name, as in the blueprint realm, it's a little bit more flexible, whereas in C++ we couldn't have a space there, but blueprints are a little different like that. Now, ground locomotion has an output animation pose. This is pose data. And if we hook it up to the output pose here, then whatever our ground locomotion returns, that's going to go into the output pose and drive our character's animation. But what does ground locomotion return? Well, if we double click on it, we're inside of it now. And up here at the top, this black bar shows us that we went from the anim graph into the ground locomotion state machine. And we can come back out by clicking on anim graph. Now notice when that happened, the anim graph tab popped up, but the ground locomotion state machine still has a tab here. So we can go back and forth by clicking on these tabs. But of course, we can also go back to the anim graph by clicking on it like that. So we have multiple ways to maneuver in and out of state machines. So we'll go back to the ground locomotion state machine, and it has something called an entry pin. Now, this state machine has the ability to have multiple states that we can switch back and forth to and from. We create a new state by either dragging off of entry and selecting add state, or simply right-clicking and clicking add state. There are multiple ways to do it, but we're going to drag off of entry and click add state. And this is what a state looks like. And we have to give it a name, and we're going to call this state idle. So I'd like to have two states, an idle and a run state. And to create a new state, we can click on the edge of one state, drag off and release, and click add state, and rename the new state. So I'm going to call the new state run. And notice it's connected by an arrow, and the arrow goes one way. This arrow is called a transition rule. We can hover over it. It says idle to run transition rule. Now, these provide us with the ability to create conditions that determine whether or not we can transition from one state to another. So they're one way. And we can transition from idle to run through this transition rule, but we can also transition from run back to idle if we click the edge of the run state and drag off, see the arrow, and release on the edge of the idle state. We'll see a pop-up that says create a transition. And if we release, we now have a second transition rule. So there are ways to provide each of these rules with conditions, and we'll get to that soon. But first, I'd like to talk more about these states. So we have idle and we have run. And we know that we can transition from idle to run and from run to idle, but what does it mean to be in a given state? Well, whatever state we happen to be in determines what our ground locomotion returns. Click back on the Anim Graph tab for a second. See the return animation pose is connected to the output pose result. So the ground locomotion will return a pose, and the pose returned, well, that's going to be whatever state we're in, and we can actually assign animations to these states. So let's go into the idle state. If we double click on it, now we're inside the idle state. And look at the bar at the top. It shows that we've gone from Anim Graph into ground locomotion into the idle state. So these have layers. They're sort of nested within one another. And notice that the idle state has an output animation pose. So whatever goes into this while we're in the idle state, that's what will be returned from ground locomotion. So we're going to stick an animation here. And I'm going to use the idle animation. So I'm going to drag it from the asset browser into the graph here and connect it to the output animation pose, just like that. And now we can go one level out back to ground locomotion. And we now know that when we're in the idle state here, we'll be playing that idle animation. Now, currently, the entry point goes straight to idle, right? And we haven't set up any logic to transition into the run state, so we never will. We'll stay in the idle state. So if we compile our animation blueprint, we'll see that our character here in the viewport is now idling. And we can see that this is the active state, and it says 100%. Now, why does it say 100%? Well, it could be partially in this state. The animation blueprint is very sophisticated. It has the ability to blend between different states, and you might be a certain percentage in one state and a certain percentage in another state. You can transition from states in a smooth manner if you want to. So right now we know that we're 100% in the idle state, but we'd like to be able to transition into the run state. And we know exactly when, right? We want to transition into run if we're running, if we're moving, if our ground speed is not 0. So let's go into the run state by double clicking it. And we have a note here. It says result was visible but ignored. This is the warning you get when you don't have anything plugged in. So Unreal Engine says, you know, there's no pose plugged in here, right? If you ever go into this state, you're not going to get any valid data. But we're going to use an animation here. Let's take our jog forward animation and drag it right on in. In fact, we can drag it straight onto that result pin and it'll be connected automatically. So now our run state has a jog forward animation that it will return when we're in this state. So back out to ground locomotion, we now have two states. And we have two transition rules, one from idle to run and one from run to idle. Now the only thing left is to program when to transition from idle to run and run to idle. So we'll start first with our transition from idle to run. That's the top arrow here, going from left to right. Now notice it has this little circle, this symbol, and if we hover over it, it shows us the condition. And if we double click, here is our transition rule, and it has this result node here, and its input parameter is a Boolean called can_enter_transition. So we can make some logic here that will return a Boolean value, and if this Boolean passed into result ever becomes true, and we happen to be in the idle state, then the transition rule is going to turn on, and we're going to transition from idle to run. So here in this transition rule, we're going to add some logic. And we do have a variable called ground speed, and we can actually drag it here into this transition rule and get the ground speed. And we can check its value here. So we can drag off of this and type a greater than symbol and select that, and we can check to see if ground speed is greater than 0 and hook that right in. Now our result no longer has a warning. It had the warning because there was nothing plugged into it, but if we compile, that warning goes away. So now we have a transition rule from idle to run. Now, this will work if we just start playing. Let's go ahead and press play and see what happens. I'm going to start running and take a look at that. We're now running, but we never programmed a way to get back from run to idle. So if I stop running, the run animation continues. We're stuck in the run state. So we need to program a way for the run state to transition back to idle. And that's this bottom transition rule here. And if we double click on it, we can add logic here. And our logic here is going to be essentially the opposite of the other transition rule. We're going to get ground speed and check to see if it is equal to 0. So we'll type a double equals, and under operators, we have the function equal, which will check to see if two floats are equal. So it'll say, is ground speed equal to 0? If so, return true. If not, return false. So this transition rule says if ground speed is 0, we will transition from run back to idle. So let's go ahead and hit play and see how this works. So we can run, we can stop, and we go back to idle. We can run again, and we can stop, and we're back to idle. So now we have running animations, and this is great. So that's how animation blueprints work. We essentially have state machines with states inside of them, right? This is the ground locomotion state machine, and these states contain poses. And when we're in one state, our state machine will return the pose that our state has returned. So if we're in the idle state, we'll return our idle pose from the idle animation sequence player here. And when we're in the run state, well, we get that running animation, and we transition using transition rules, which contain logic, and these always return some Boolean value, true or false, and whenever that value evaluated in the transition rule becomes true, if we're in a state connected to that transition rule, we'll transition through that arrow to the state pointed to by the arrow. So that's kind of how those work. So now that we have an animation blueprint, we can make more and more complex state logic. For example, we may want to jump and transition into a jump state that's playing a jumping animation. So these can get very complicated very quickly. This is a simple example, but we'll be getting more complicated throughout the course. And here in the anim graph, we have our ground locomotion state machine, but you can create more state machines and have our character doing different things depending on what's happening in the game, which is really exciting because we're going to want Echo to be swinging swords and killing monsters and things. So we'll get to those soon. So great job. We now have animation. We can now run around in the world. We still can't jump. We'll get to that soon, but we've created an animation blueprint. But this is a blueprint, and all blueprints are based on C++ classes. So how do we create a C++ class to drive the data behind the scenes from the C++ side? We'll get to that in the next video. I'll see you soon.